I love Canaletto's because Canaletto has this fantastic detail, and you can get right up, and really just get right up and see all the details on the painting. And I started across the hall in North Carolina because I thought it was probably a Canaletto and would have all that detail. And I noticed that the bridge there's a lot of people. You can just barely see them walking across the bridge. And I thought as I got closer, I would be able to see all the detail on those people, and see their clothes and so forth. And as I got closer and closer, I actually screamed. I yelled out because when I got close, I found the detail wasn't there at all. It was just little artfully placed blobs of paint. And as I walked towards the picture, I was expecting detail that wasn't there. The artist had very cleverly suggested people and clothes and wagons and all sorts of things, and my brain had taken the suggestion. You're familiar with a more recent technology, which is there. You can get a better view of the blobs. See, they're really, when you get close, they're really just blobs of paint. And you will have seen something like this. So this is the reverse effect. Just give that to you one more time. Now, what does your brain do when it takes a suggestion? When an artful blob of paint or two by an artist suggests a person, say, does some of Marvin Minsky's little society of minds, did they send little painters out to fill in all the details in your brain somewhere? I don't think so. Not a chance. But then how on earth is it done? Well, remember the philosopher's explanation of the lady? It's the same thing. The brain just makes you think that it's got the detail there. You think the detail's there, but it isn't there. The brain isn't actually putting the detail in your head at all. It's just making you expect the detail. Let's just do this experiment very quickly. Is the shape on the left the same as the shape on the right rotated? Yes. How many of you did it by rotating the one on the left in your mind's eye to see if it matched up with the one on the right? How many of you rotated the one on the right? Okay. How do you know that's what you did? There's in fact been a very interesting debate raging for over 20 years in cognitive science. Various experiments started by Roger Shepard, who measured the angular velocity of rotation of mental images. Yes, it's possible to do that, but the details of the process is still in significant controversy. And if you read that literature, one of the things that you really have to come to terms with is, even when you're the subject in the experiment, you don't know. You don't know how you do it. You just know that you have certain beliefs. And they come in a certain order at a certain time. And what explains the fact that that's what you think? Well, that's where you have to go backstage and ask the magician. This is a figure that I love, Bradley, Petrie, and Dumas. You may think that I've cheated, that I've put a little whiter than white boundary there. How many of you see that sort of boundary with the Necker cube floating in front of the circles? Can you see it? Well, in effect, the boundary is really there in a certain sense. Your brain is actually computing that boundary, the boundary that goes right there, the boundary that's going right there. But now, notice there's two ways of seeing the cube, right? It's a Necker cube. Everybody can see the two ways of seeing the cube? Okay. Can you see the four ways of seeing the cube? Because there's another way of seeing it. If you're seeing it as a cube floating in front of some circles, some black circles, there's another way of seeing it. As a cube on a black background is seen through a piece of Swiss cheese. Can you get it? How many of you can't get it? That'll help. Now you can get it. These are two very different phenomena. When you see it, the cube one way, behind the screen, those boundaries go away. But there's still a sort of filling in, as we can tell if we look at this. We don't have any trouble seeing the cube, but where does the color change? Does your brain have to send little painters in there, and the purple painters and the green painters fight over who's going to paint that bit behind the curtain? No, your brain just lets it go. The brain doesn't need to fill that in. Aha. When I first started talking about the Bradley Petrie Dumai example that you just saw, I'll go back to it. This one. I said that there was no filling in behind there, and I suppose that that was just a flat truth, always true. But Rob Van Leer has recently shown that it isn't. Now, if you think you see some pale yellow, I'll run this a few more times. Look in the gray areas, look in these gray areas, and see if you seem to see something sort of shadowy moving in there. Yeah. Yeah, it's amazing. There's nothing there, and there's no trick of that. This is Ron Rensick's work, which was in some degree inspired by that suggestion of mine at the end of the book. Let me just pause this for a second, if I can. This is change blindness. What you're going to see is two pictures, one of which is slightly different from the other. As you see here, the red roof and the gray roof. And in between them, there will be a mask, which is just a blank screen, for about a quarter of a second. So you'll see the first picture, then a mask, then the second picture, then a mask. And this will just continue. And your job as the subject is to press the button when you see the change. So, show the original picture for 240 milliseconds. Blank. Show the next picture for 240 milliseconds. Blank. And keep going until the subject presses the button saying, I see the change. So now we're going to be subjects in the experiment. We're going to start easy. Some examples. No trouble there, huh? Can everybody see? All right. And indeed, Rensick's subjects took only a little bit more than a second to press the button. You see that one? .9 seconds. How many don't see it still? What's on the roof of that barn? That's easy. Is it a bridge or a dock? There's a few more really dramatic ones, and then I'll close. I want you to see a few that are particularly striking. This one because it's so large, and yet it's pretty hard to see. You see it? See the shadows going back and forth? Pretty big. So 15 and a half seconds is the median time for subjects in his experiment there. I love this one. I'll end with this one. Just because it's such an obvious and important thing. How many still don't see it? How many still don't see it? How many engines on the wing of that Boeing? Right in the middle of the picture. Okay. Thanks very much for your attention. What I wanted to show you is that scientists, using their from the outside third-person methods, can tell you things about your own consciousness that you would never dream of. And that, in fact, you are not the authority on your own consciousness that you think you are. and we're really making a lot of progress on coming up with a theory of mind. Jeff Hawkins this morning was describing his attempt to get theory, and a good big theory, into the neuroscience, and he's right. This is a problem. Harvard Medical School, once I was at a talk, the director of the lab said, in our lab, we have a saying. If you work on one neuron, that's neuroscience. If you work on two neurons, that's psychology. We have to have more theory, and it can come as much from the top down. Thank you very much.